Good afternoon, everyone. First of all, I'm no public speaker, so if there's any fumbles over the next 20 minutes, you'll excuse me, but I'll thank Peter Taton for setting the bar so low. There's a risk with telling this story. It's a risk that I'm seen rocking the boat or being a bit one-eyed, or I don't support my CAD colleagues and I want their job. It's not true. I just simply want to ensure that we all have jobs. This story started back in 2011 when a team I was working with won a huge design project on the Great Western Highway. I became involved at October 2012 when the project scope was extended to include another 3.5 kilometres of concept and detail design around Mount Victoria Village, which is down there in the bottom right-hand corner. At that stage, the team had 20 or so people had been at it for months. Everyone was working flat out and our office space was full. There was no one available to help with drafting for several weeks into the future, and even then, the CAD team would give us no promises. With so much hinging on the preparation of drawings, we were not confident we had anyone at all to do the CAD tasks. The design program, however, required the first preliminary concept drawings due less than a month after we started. 15 years earlier, I'd seen 4D used to produce thousands of drawings at Connell Wagner here in Brisbane during planning for the first South East Transit project from South Brisbane out to the edges of the city. At that time, I was a keen AutoCAD and MOS user, and so I found the choice of drafting package quite interesting and inquired into it. And I was told that AutoCAD took about 10 minutes to open a drawing, plot the drawing, close down and open the next one, and there were thousands of them to do. It simply wasn't going to be an option. And because 12D worked in a single environment, it was able to plot the drawings directly much quicker. So back onto the Great Western Highway project. 12D was already being used for all of the survey and design tasks, and I began to wonder whether what I'd seen 15 years earlier could help us meet the short deadlines. I made a suggestion to try 12D's unknown CAD abilities. Being an alliance project, we required buy-in from the JV partners and our client, the RMS. Soon we had agreement to proceed with 12D for CAD, subject to one condition, that the presentation style from 12D must match the larger project exactly. This was a bit of a challenge since the larger project was being done in two different CAD design and CAD programs. But we had a plan to proceed with 12D until such time as a CAD resource became available and/or we hit the limits of what 12D could do. The first drawing to be produced was a long roll plot, nearly 3 metres long with a 4.5 gigabyte aerial image in the background. Using AutoCAD, that kind of drawing could be very problematic. But the whole thing in 12D, from creating the drawing sheet and the finished plot, went very smoothly. I think it was about an hour's worth of work. For comparison later, I asked our lead drafters to produce the same plot, and the end result was they crashed 3 machines and it took them several hours to get it out. It's worth noting that RMS briefs, professional services contract briefs, require a Genio or 12D file to be handed over and PDFs. At no time do they ask for anything like a DGN, a DWG, or anything like that. So, how did it go? Pretty well. Yes, there were teething issues. Many of the issues were not 12D at all. We had some issues with our operating systems, and perhaps the main one was that when we started, we were using the production drawings that were being done on the other part of the project as a template for how our drawing should look. And we continually discovered that things weren't that standardised. Text heights, colours, thicknesses, all varied subtly from drafter to drafter. The AutoCAD drawings were almost cursed with individual settings in many thousands of files. Kind of reminds me of this cartoon I found once. Our road team was the design team, our project team, was 2 road designers, 2 drainage engineers, and a grad looking after utilities. We're all responsible in the end for preparing our own drawings, so that's quite a change from what normally happens. But there was a steep learning curve for all of us, and 3 of those 5 had never prepared a CAD drawing in their life, but they were pretty comfortable after a short time with 12T. In the end, we produced a good design on time and with good quality drawings, looking near identical to their project peers in presentation. Budget-wise, we spent a little bit more on the 12D time, but significantly less on CAD. By the end of the concept design, the project was about $10,000 under budget, and anyone who's worked on an alliance will know how momentous that is. There's basically no incentive to be under budget on an alliance. No, it's just me. And it should be noted that the investment that we had in the learning of how to do this in the system was largely a one-off cost. But by comparison, what normally happens in CAD production, it's a continual, labour-intensive, costly exercise. I'll just walk through some of the samples of the drawings now. So the presentation-wise, these were all done to match the larger project that we had. So starting with the road plans, the GAs, or the if you like, the faded aerial image in the background. You've got your road design model is showing there. To remove cars and trucks from the road surface, there's a faded fill across the road surfaces. There's scale bars and plot and a series legend on the right-hand side, specific to that drawing. Drainage layouts was a little bit similar. It's not easy to see these from 100 miles away, I know. But you've got your contour and survey backgrounds. We've got some hatching coming from AutoCAD.pat patterns. Again, the road models are shown, the drainage models are shown as we want them to show. There's no manual work's been put into that. And then on the left, we've got a dial before you dig warning, which is a JPEG or something, and a legend specific to this series. Did the utilities, all of the utilities modelling was done and presented like this. This was the project standard for this work. We've got those call-outs there for the very congested areas. Road long sections. This stuff is all generated direct from the model. We didn't see any point to go putting it into an intermediate system. You go from a model to something else, and then you get back to a PDF. It was kind of a pointless round trip. So, yeah. Cross sections. The only difference from what you're probably doing now to this is the inclusion of the sheet. You're probably nearly there. We did the construction staging diagram, so there were three main stages. We had different polygons representing construction stages and some thick superstrings representing through traffic. So the main benefit of all of this is that a whole series of drawings can be turned around in about 5 minutes. There's some other benefits as well. So keeping the designer in control of the finished product was quite handy. There's less blame shifting or flick passing of task. I'll just let the CAD guys look after that, and the CAD guys go, no, that's a designer's job. You've got to sort that out. It's great for consistency. So all of the drawings come out with, because it's all done through a scripting process, the consistency is there. We didn't need to finish the design 2 weeks before they were required, so we could design right up until Friday lunchtime and have them out by Friday 4 o'clock. And the drawing quality itself was pretty crisp, which does look good once it's printed, and I'll talk a bit more about that in a minute. In the end, the client was happy with the product, the project directors and managers were happy, and the team was more relaxed than usual in leading up to the deadline. We all enjoyed the experience and were keen to do it again. But really the main benefit is all about turning those drawings around in 5 or 10 minutes. Next up, just wanted to look at what the typical workflow is involved in producing a road design drawing to PDF, which is, again, where where the drawings need to go. So the road design ends. You run a script to plot the sections. You do a file export. You document the file revision. You log into a file transfer system. You navigate to a specific location. You copy and paste from Explorer to the file transfer system. You do something with a revision code. You email the CAD lead guy. You wait while he returns from his meeting. He forwards it on to someone else. The CAD operator finishes lunch. Then he inspects your work. He supersedes the old XREF. He places the new data in place of the old. And then he runs a plot or a publish routine. And then you get some PDFs. So along the bottom of the view there, you've got some icons to show what the typical system entails. Assuming that you amended a verge and a batter arrangement and nothing else, the quickest you could hope to see the new plan drawings could be measured in hours. What else is wrong with the workflow? It's very disjointed. It relies on numerous complex systems. It generates distracting emails, generates lots of non-productive work, generates numerous intermediate files, each requiring its own systems and revision control and specialist systems and people. And the people responsible for the final outputs often have no idea of the engineering content, so is clueless in correcting or highlighting issues and often misinterpret things. Because CAD people don't necessarily know the content of a design, we see them incorrectly applying edits from one road to another or misinterpret a markup note. Something like fix on all sheets. To me, that instruction should mean apply this correction to all 10 sheets. It would never mean to enter that text, fix on all sheets, onto one drawing. But I know you've all seen it. Quite recently, I heard a radio interview where the interviewee was talking about studies being done on humans and multitasking. The message was, humans cannot multitask. We only have one brain. It can't perform more than one task simultaneously. The best we can do is continually switch task. And studies are proving that switch tasking means that we cannot give everything to the task at hand. Instead, there's a continual mental interruption preventing full focus on any one of the tasks. And that none of the tasks will be done well. Switch tasking is bad for productivity. It's good in computing, but bad in humans. Now, I think that the typical design office, which I've got up there, the workflow, is akin to multitasking. All those steps, they all need doing. They all demand full attention. And they all demand full attention. And then you get an email about you get 4 emails about file transfers, and then you get one about this week's flight holiday specials and the news from the Big Brother house. And then Peter comes over wanting to talk about the State of Origin results. It's just, when you're doing all those steps, it's all prone to interruption. And while we don't have Clippy anymore, when you've got that email pinging in the corner and you're doing lots of little repetitive steps, it's prone to breaking down. The serious point is that the tasks alone don't appear taxing, but my experience in several firms is that turning around a simple drawing amendment can take hours or, sometimes days. And it requires numerous expensive resources. Now, to compare the process that we got to on that Great Western Highway project. The road design end, we ran a script to plot the sections and compile the drawings. That was it. I was a bit hesitant to put the 2 workflow slides side by side out of fear I'd be seen as unreasonable or picking the most favourable situation to prop up my argument. It seems too good to be true. But because it's not the file structure that I'd recommend you do, I'll expand that little process out in full. So the road design ends, you save the project. Switch to a project where you're doing the CAD production from, so that you're not mixing the design and the drawing in the same environment. Then, reload the shared data and then run the script. So, that first slide wasn't the full story, but it's not too far off. I mentioned before the quality of the 12D PDFs in this, and it's a bit extreme to zoom in to a PDF to this scale, but it does illustrate my point that the drawings were very crisp, and Phil McSherry was responsible for that, I think, and he ought to be commended. The two, I'm not sure whether it was AutoCAD there on the left, but I just picked those up off the net last night, a couple of examples. But you would have seen those with images and logos, and the kind is, they're very, very jagged, not very smooth. And on the right-hand side there, they're out of our project, very crisp, very clear. So how is it done? So it's all done via chains, and if you don't know how to script stuff together in a chain, you really ought to. Looking at the road long sections, these are basically the steps. You can get more funky you can get quite funky with more and more steps and post-processing and pre-processing, but essentially this is it. The long sections are plotted to a model, and then I use a model, a macro, which I think Sam might have been responsible for once upon a time, which moves each sheet into a long row. So rather than all of the sheets sitting at 0, 0, they get sort of spread out into a long row. And then move them all to a single model again, because it's easier to deal with one model rather than 100 different models, all showing just sheets. Manual CAD notes are added then to that model space. And the last step there is that the plan plot frame, so rather than plan plots, which might usually sit up in, on a road centerline, they're just sitting down in that same row. And they're plotted to PDF, and they contain the title block information, scale bars, legend, north points, not that you'd have a north point on a long section, sheet frames, project and consultants logos. The plans, the plans take a bit. The plans do take more steps, but it's not that much different. First of all, there I was setting the DPI for the raster image, and then it looped into into this chain, which it cleans a view plots, and if plots doesn't exist, it gets created, and then we just go adding the models that you want to see on the view. So, usually it's add the raster, then add the survey models, add cadastral models. These are just grouped models which will all have a common prefix. Add tadpoles, shading, the design strings, join lines, add the road names, chainage labels. And once that's done, you're back into that top level chain. And for each of our sheets, they had their notes in model space, so that only the notes on sheet 1 would be seen on sheet 1. You wouldn't get any notes from sheet 2 bleeding around the edges. So we did them all on unique models, which is they're called, I can't see what it's called. Yeah, so you'd add the notes, plot the frame, and then remove the notes. So for the next sheet, the same thing had happened, but it would all be related to sheet 2. And it would loop through all of them. Might add that you don't need to do that one at a time process. You can do them all at once, but just the way that the project presentation had to be done, that was a bit of a long-handed way of doing it, but that's what was needed to be done. How are we going for time? You happy to keep going? I can stop there if you like. Keep going? Okay. So some tips. If you have a model naming convention or a prefix naming convention, it would probably need to be expanded. We very purposefully decided to use the same colour and pen weight system that we always have in AutoCAD, And we configure both the 12D and the ACAD colours to be the same, so that red would plot the same as ACAD 001. You know, it's pretty obvious, really. Planned plot frames. When you plot a whole model, they're plotted in the order that they exist in the model. So you just need to be careful that that's the order that you create them. After the planned plot frames that are created along a string, it's handy to round their rotation to 5 degrees. It just makes adding notes and things later that much easier. And we used big long chainage ticks to create the join lines between sheets. I think our A3 sheets at 1 to 500 or 1,000, you could get about 300 metres length. So we'd just do these big chainage ticks every 300 metres. And that would become our join lines then between the sheets. If you need to do more than one plan or one thing on a view, at least in version 10, you had to plot to a model first. Otherwise, you weren't able to do 2 viewports. When plotting sections, we use the plot management macro to move the sections into a long row. And then we had some plot frames which were down in that space around from starting at 0, 0 and went along. We had as many, and then you have as many there as you have long and cross sections to plot. So I think for our project we had 31 sheets of long sections, and I can't remember how many sheets of cross sections. So the tools, or the things aren't that unfamiliar here. Anyone who's done anything in AutoCAD and anyone here who's done anything in 12D, the concepts are very, very similar. Perhaps the most crucial is probably the AutoCAD would call the CTB colour table. I don't know what that stands for. But in 12D, the equivalent is a PMF, and it's just where you assign a colour to be assigned a pen weight on the final drawing. Yeah, so that's it.